And this is Euclid Book 4, proposition number 12, part 2. We just got through proving that this angle is equal to this angle, and this angle here is equal to this angle because triangle KBF is exactly the same size as FCK. If these two triangles are exactly the same size, then this angle is going to equal this one, and this angle is going to equal this one. Alright. Now, angle BFC. Well, where's BFC here? BFC. This angle right here is going to be double the size of KFC. Well, here's K, here's F, and here's C. And we can say that because if you were to add the angle BFK here and KFC here, if you were to add these two together, it would be the same size as BFC here. Okay, and let's see, we have BKC. Well, where's the angle BKC? Well, here's B, here's K, and here's C. There's that one right there. And it's going to be twice the size of FKC. Well, where's FKC? FKC. So this one here, this whole thing right here is going to be double the size of this. Okay. Now, angle CFD. Well, where's CFD? Well, here's C, and here's F, and here's D. This angle right here is going to be twice the size of CFL. CFL. Now, how do we know this? Because we can go on to prove that triangle FCL is exactly the same size as FDL. And I bet you're saying, well, how in the world are we going to prove that? Well, we can first of all establish that the length of FC and the length of FD are exactly the same size because all radii of a circle are equal. And we can go on to say that FL and FL are exactly the same size because they're equal to themselves. And then we can go on through the Pythagorean proof. We can say that the squares of FC and CL are equal to the squares of FD and DL, and since we already know that the square of FD is equal to the square of FC, then we can go on to say that the square of CL is equal to the square of DL, so therefore the length of CL is equal to the length of DL. Whew. Say one more time? Okay. We've already established that length of FC and FD are exactly the same. We've also established that through perpendicular lines that, because the FD is perpendicular to DL, so this is going to make a 90-degree angle here, and FC is perpendicular to KL, so FCL here is a 90-degree angle there. Alright, so what we're trying to do is prove that triangle FCL here, FCL is the same size as FDL here. And we can do this by first of all saying that the length of FC and the length of FD are exactly the same size due to the fact that all radii of a circle are equal. We've already said that FL is equal to itself. Okay? And then we're going to go on to say that if you were to add the square of FC and CL, it would come out the same total as adding the square of FD and DL. And if that being so, then if the square of FD and the square of FC are equal in size, then the square of CL and the square of DL are exactly the same size. So therefore, CL is equal to DL in length. Whew. All right. And that makes angle CFD, we got angle CFD. Well, where's CFD? CFD, it is twice the size of angle CFL. Well, here's CFL. Now, we already said that CFL and LFD are exactly the same size because these two triangles are exactly the same size. So, angle CFL is going to be half of angle CFD. Okay. DLC. Well, where's DLC? Well, here's D and here's L and here's C. Okay. Now, we already established early on that DLF was the same size as FLC. And if that being the case, then we can then say that DLC is twice the size of DLF. So far, so good. And we can go on to say the DLC is twice the size of FLC. Alright. Now we've already established that the circumference of BC, right here, is equal in size to the circumference of CD. And because of that, we can then go on to say that angle BFC, well, where's BFC? Well, here's B and here's F and here's C. This angle right here is equal to CFD. CFD. So this angle here and this angle here, BFC and FCD, are equal in size. Or at least they're supposed to be. And we can prove this by Euclid Book 3, proposition number 27. And now we'll go on. Now, angle BFC is twice the size of KFC. KFC. Already established that. DFC. Where's DFC? DFC is twice the size of LFC. LFC. Okay? That makes angle KFC, KFC, this angle right here, equal in size to LFC. LFC here. So this angle is equal to this angle. And that also makes FCK, well, let's see, where's FCK? Well, this one's FCK right here. And FCL, FCL, these are both 90-degree angles and therefore equal to each other. Whew. And that means that we have two equally sized triangles. FKC, FKC, this whole triangle right here, is equal in size to FLC. FLC. These two triangles are exactly the same size. And that makes line KC equal to line CL. And that makes angle FKC, FKC, this one right here, equal to FLC, FLC. This one is equal to this one. And that makes line KC equal CL. Well, where's KC and CL? Alright, then length of KL is twice the size of KC. Because if KC and CL are exactly the same size, then twice of KC would be KL. Alright, now let's go to HK. Here's HK. Now what we could have done here is we could have drawn a line from point F to point H here. Okay, we could have done that. And then we could have gone through the perpendicular lines and the whole 9 yards and so on and so forth. It'd have been a real pain in the behind because we could have drawn a line from F to H and then a line from F to A and gone on with a whole dang goobly-goo proof. But we're not going to do that. If you want to do that, that's fine. If you want to videotape it, go ahead and post it up to me. HK equals 2BK. Well, here's BK. Twice the, well, BK equals BH. So twice the BK is HK. And BK equals CK. Well, here's BK and here's CK. We've already proven that. And HK equals KL. HK here equals the length of KL here. And we could go on and on and on with this proof. And we could eventually prove that HG, well, here's HG here. and GM and ML and HK and KL, all 5 of those lines are equal in size. So that makes pentagon GHKLM, GHKLM, pentagon GHKLM is equilateral, and I will tell you more in the next video, so stay tuned.